3.8, day number 1, implicit differentiation. So before we get started here, I want to make one quick correction on the notes. That should be relation instead of function. Okay, so here's an example of an explicit. Here's an explicit function. Okay, so for example, y equals x squared, right? Where we can isolate the function in terms of x. An implicit relation might be something like x squared plus y squared equals 4, right? Where we can't necessarily isolate. Another one might be x times y plus y squared equals 8. Right? That's implicit because I can't isolate one of the variables. So implicit differentiation allows us to find derivatives of functions that are not defined or written explicitly as a function of a single variable. If we have solved for y in terms of x, then we have explicitly defined the function. But sometimes we can't do that. For example, right here you see xy equals 1. It's implicit. What would be the explicit equation? Right? So the explicit equation would be y equals 1 over x. So let's find dy dx using both forms. Okay, so if I were to, first before I do this, if I did d dx of x, right, I get 1. If I did d dx of y, I get dy dx. Okay, so in the second example, we're taking the derivative of y with respect to x. So we have not been able to explicitly determine it like we could here, right? We came up with the slope of that curve at any point is 1, but we don't know the slope of this curve because we don't have it defined in terms of x. So let's go ahead and do a little implicit differentiation on both of these. So if I did the derivative of y equals 1 over x, I'm going to do the following. I'm going to take d dx of y, set that equal to d dx of 1 over x. I'm going to go off camera for a moment and come back with an answer. Okay, so as you can see, I split this up. I took d dx, or the derivative of y with respect to x, which is dy dx, and I did the derivative with respect to x of 1 over x, changing this into a power rule form, which gave me the derivative. The derivative is going to be negative 1 over x squared. That would be the general derivative. Okay, so let's do this implicitly now in part B. So now I'm going to do d dx of xy, xy equals 1. Again, I'm going to split that up. Take d dx of x times y. You might see a product rule coming here. Times d, or equals d dx of 1. Okay, so d dx of 1, right, the derivative of a constant is going to be 0. If I did the derivative with respect to x of x times y, I would have to do the chain rule. So derivative of the first times the second plus the derivative of the second times the first. Okay, so that'd be x times dy dx. Okay, so here we go. We got some work to do. We got y plus x times dy dx equals 0. Okay, I want to isolate now. I want to isolate dy dx. So I subtract y and divide by x. So dy dx would equal negative y over x. Okay, now one thing I want to isolate here is, what is y? Well, from before, remember y was 1 over x in part A. So this would equate to negative 1 over x, right, that's this piece, negative 1 over x times this piece, which is 1 over x, which comes out conveniently to be negative 1 over x squared, just like we got in the previous one. Okay, let's go through this one here. I'm going to run through it relatively quickly, but let's do it. So d dx of x squared minus y squared equals 1. Okay, I'm not going to split this up each time, but you'll see what I do. Actually, you know what, I will on this one. So d dx of x squared minus d dx of y squared equals d dx of 1. So d dx of x squared is 2x. Here I've got some chain rule to go for here. So I got 2y, right, times the derivative of y with respect to x. And that'll equal 0. So to find dy dx, I just isolate. So I'm going to subtract 2x squared and divide by negative 2y. So I'll get negative 2x squared over negative 2y. So it looks to me like dy dx will equal positive x squared over y. Now we have no origin for y, therefore I'm just going to leave it like that. So I'd leave dy dx equals x squared over y. Whoops, I made a mistake. I found it before I got too far ahead. This would just be 2x. So this would just be 2x, so this would just be x over y. Next example, d dx of xy squared equal to x minus 8. Okay, separating that up. Okay, we get that. I'm going to go off camera for a moment and do some product and chain rule over here on the left. On the right, clearly the derivative of this would be 1. So I'll come back with an answer on the left. Okay, so chain rule. I took the derivative of the first times the second plus the first times the derivative of the second. So this right here, 2y times dy dx is the derivative of the second. Alright, go ahead and isolate that. Okay, isolating dy dx, I get 1 minus y squared over x times 2y. Okay, some mathematicians prefer that all numbers come before variables in any given term. So I could leave it like this. That would be implicitly differentiating that problem. Okay, find dy dx given that x plus x times y plus sine xy equals 1. Alright, let's write out the beginnings of this. I'm going to split it up immediately. Looks like we got some chain rule, we got some product rule. Yeah, we got some good stuff going on here. Okay, so the first piece here, this would be, looks like product rule, so 1 times y plus x times dy dx. Plus, looks like chain rule here, we would go cosine of xy times the derivative of the inside. The derivative of the inside would be a product rule. Okay, so we got some work to do here. So product rule there would be 1 times y plus x times dy dx. And the derivative on the right side would be 0. I'm going to clean this up a little bit. I'll come back with some nicer looking material here. Okay, I moved the 0 over here, but I've just got y plus x dy dx plus cosine. I distributed the cosine xy to both of these terms. So I get cosine xy times y and cosine xy times x dy dx. Now I want to get those x dy dx's together. So I'm going to go y. I'm going to move this term right here over and go y cosine of xy. And then I'm going to group these two right next to each other and pull out a dy dx. So I got dy dx, I pulled out of both of those. That leaves me with x out of this one and x cosine of xy in that one. So let's get some stuff all alone here. It looks like I'll get minus y cosine of xy. And then I'm going to divide it by positive x plus x cosine of xy. And that should be dy dx. Ooh, yeah, look at this one. Okay, we got some work. Let's write it out together. I gotta save some space here. Let's take the derivative with respect to x of y squared sine of y plus x, oops, let me split this up while I got it, plus d dx, ooh, it makes that one look nice, x squared minus d dx of 4xy. And that'll equal 0. Okay, so product rule, chain rule here, we got a lot going on. Let's do this piece. I'm going to go off camera for a moment. Okay, a lot going on here. Let's take a look. Here is my derivative. That is just nasty. There's some chain rule and product rule going on there. That was thank you very much. This right here, I factored out the -4 and then just did the product rule and chain rule regarding x times y and got that. So in the red one, I factored out a dy dx. And the green one, I distributed, right? I got -4y and -4x dy dx. I moved the -4x dy dx over here so I could pull the dy dx out of that and then just group the -4x in this big long term. Here I took the -4y and the positive 2x and moved them over to the right side. So all that I'll get for the derivative, or dy dx, is I'm just going to take, whoop, better leave that there, I guess. I'm just going to take -2x plus 4y, and I'm divided by this massive expression here. And hopefully I don't screw it up as I'm trying to write it out. Alright, now I'd leave it just like that. That would be your derivative of y with respect to x differentiated implicitly. That is 3.8. I think it's 3.8, is it? Yeah, that's 3.8, day number 1, implicit differentiation.